Welcome to The Deep Dive. We're the podcast where we take a big stack of information, sift through it, and pull out the most important bits of knowledge and insight just for you.
Glad to be here.
Today, we're embarking on a really captivating deep dive. We're looking into a suite of advanced geophysical exploration technologies, and also a powerful predictive algorithm that frankly sounds almost mind-bending.
Mm-hmm.
Our sources for this, they range quite a bit. We've got detailed technical reports, company profiles, even some personal documents. It gives us a pretty unique window, I think.
Definitely. A window into a world that really aims to redefine how we find resources. Oil, gas, minerals. But it goes even further.
Yeah, that's the really wild part.
What's truly compelling, I think, is that we're looking at a system that doesn't just promise to revolutionize that resource search deep underground. It also makes these, extraordinary claims.
Right.
Claims about extending its predictive capabilities into areas like financial markets, medical prognosis, even geopolitical conflicts.
It's a lot to unpack. So our mission today is basically to explore the core science, look at the practical applications, and dig into those ambitious claims.
And see how it all connects.
Exactly, how it connects to real-world projects and some pretty surprising contexts, both historical and current, maybe even a bit controversial in places.
Right.
Okay, so let's start at the foundation, the technology itself. At the heart of this deep dive, you've got two main non-seismic methods. First, there's high-resolution electroinvestigation with induced polarization, or HRE, GA for short.
HRE.
And then it's even more advanced form, anisotropy frequency sounding with induced polarization on laser beams. That's AFS-IPLB. Quite a mouthful.
It is. And to put these into perspective, the goal here is really to move beyond traditional seismic methods. The sound waves, they bounce off rock layers.
Right.
These use electromagnetic signals instead. So AFS-IPLB, for instance, it's described as using orbiting satellites.
That's like so.
Yeah, to transmit and receive low-frequency signals. And these signals are apparently generated by something called magnetic loops.
Magnetic loops. Embedded in lasers.
Embedded within high-frequency, high-energy laser beams that are directed down at the Earth's surface. And the key concepts here, induced polarization. That's about how some rocks can sort of temporarily hold an electrical charge.
Okay, like a tiny battery.
Kind of. And anisotropy means they measure how electrical resistance changes depending on the direction you measure it. That gives you much more detailed information about what's down there.
Got it. And what really makes this stand out, I think, is the depth they're claiming.
Oh, absolutely.
Conventional, high-frequency electromagnetic methods, they're usually pretty limited, right? Like less than 30 feet deep.
Yeah, very shallow stuff usually. Ground-penetrating radar, things like that.
But AFS-IPLB, they claim it can reach depths comparable to seismic, up to 10 kilometers down.
Kilometers. That's huge. If it holds up consistently, it would be a paradigm shift.
A total game changer. So the obvious question then is, what can it actually find down there at 10 kilometers?
Right. Well, the primary application is finding hydrocarbons. Oil and gas, basically.
Makes sense.
But it's also used to identify saltwater deposits, which can be important in oil exploration, too. And interestingly, kimberlite pipes.
Kimberlite. Those are the diamond-bearing formations.
Yeah.
Carrot-shaped things.
Exactly. Often associated with diamonds. So multiple types of resources.
Okay. And what about the practical side? The actual field work for, say, HRES-IP. How does that work?
Well, it involves laying out these long horizontal electric lines on the ground. They call them source lines. And they integrate that with data from surveys done directly inside existing wells, if available.
So pretty involved on the ground.
Oh, yeah. We're talking about some pretty robust equipment, computerized generator arrays powered by diesel generators, big ones, capable of up to 100 kilowatts.
Wow, that's a lot of power.
It is. And that power, combined with GPS synchronization for their measuring stations, that's what lets them push those signals deep and measure the faint responses accurately, far more so than many conventional methods.
Okay.
And the setup is designed for resilience, too. They use grounded electric lines, the source lines, that can stretch up to 30 kilometers.
30 kilometers, that's massive.
Huge scale. And they measure the horizontal electric components of the field response. What's also key is they say the method minimizes environmental impact.
That's a big plus these days.
Definitely. And it can operate in basically any climate zone, deserts, Arctic conditions, you name it. They also really emphasize its ability to filter out noise.
Noise, like electrical interference.
Yeah, 50 hertz electrical noise from power lines, but also wind noise, traffic noise, even noise from people walking nearby. Getting clean data is absolutely critical.
Makes sense. You need a clear signal from that deep.
Uh-huh.
Okay, so you collect all this incredibly complex data from potentially kilometers down. How do you possibly make sense of it?
Well, that's where the brain comes in, as you called it.
That's right.
The RALF1 algorithm. RALF stands for Reflection on Actions of Lorentz Forces Vector 1. It's a patented software product developed by a guy named Vadim Chernov.
Lorentz forces.
Yeah.
Okay, refresh my memory. That's about electricity and magnetism interacting, right?
Exactly. The fundamental forces between electric currents and magnetic fields. So the core idea behind RALF1, it's described as a way to mathematically map the effects of these Lorentz forces
Map them onto what?
onto the properties of a physical body or even space itself. Essentially, they claim the algorithm models these fundamental forces to figure out the characteristics of whatever they're scanning. It's a pretty profound concept.
Yeah, it sounds it. And this is where the claims get even more, well, compelling, maybe even a bit startling.
You'd say that.
The creators say RALF1 is the key to solving the main problem of quantum physics, the problem of observer.
Right. That's a huge claim.
It links directly to Thomas Young's double-slit experiment.
Yeah.
You know, the one where light acts like a particle or a wave, depending on whether you're watching it?
The classic quantum weirdness, the act of measurement changing the outcome.
Exactly. And they claim this algorithm replaces the human observer. It provides a mathematical basis for that phenomenon.
Which for many physicists would sound, well, highly speculative, let's say, but they present it as absolutely fundamental to how their technology works.
Okay, so bring that back down to Earth, or rather under the Earth.
Yeah.
How does this RALF1 actually get used in geophysics?
Right. Practically speaking, it's used to analyze those key electrical parameters we talked about. Resistivity, how much rock resists current.
Okay.
Resistivity anisotropy, how that resistance changes with direction. And polarizability, that ability to store a temporary charge.
So it maps all that out.
Exactly. Across the whole geoelectric section, down to 10 kilometers or even more. And by analyzing those patterns, it identifies the telltale signs of hydrocarbons.
Like what specifically?
Like a local increase in the reservoir rock's resistivity, because oil and gas don't conduct electricity well. Also, a reduction in polarizability compared to rocks filled with water. And increased anisotropy, that direction-dependent resistance in those non-conductive hydrocarbon deposits.
So it's looking for a specific electrical fingerprint.
Precisely, a multi-parameter fingerprint.
And the precision they claim. That's pretty remarkable too, isn't it?
It really is. They assert a proven accuracy of just 2 meters in calculating where the hydrocarbons or highly saline water are saturated, even at 10 kilometers deep.
2 meters at 10 kilometers. That's astounding accuracy if true. Revolutionary, really.
Absolutely. And it's not just for the easy places, the typical sedimentary basins.
Right, you mentioned challenging formations.
Yeah, they claim it can detect hydrocarbon reservoirs even in crystalline formations like granite.
Granite. But isn't granite usually considered basement rock, not reservoir rock?
Typically, yes. But they point to places like Vietnam's White Tiger Basin, where oil is found in fractured granite basement. They claim they can find reservoirs even under a kilometer of solid granite at depths of 3 to 4 kilometers.
Wow. Okay, that opens up entirely new possibilities for exploration.
It certainly would. And the software itself, the RALF1 Python script, is apparently designed for efficiency. It uses parallel processing, leverages multiple CPU cores.
Which you'd need, I guess, to crunch those massive data sets.
Definitely. You're dealing with huge amounts of data for that kind of depth and resolution.
So, okay, this all sounds incredibly advanced. How much is this actually being used in the real world? Is it just theory or?
Oh, no. It's definitely in use. According to the documents, this HRES IP technology is being used by some major global players in the oil and gas sector.
Like who?
Companies like Rosneft, Lukoil, Gazprom in Russia, the National Iranian Oil Company, NIOC, China National Petroleum Corporation, CNPC.
So some big state-owned enterprises.
Exactly, with operations mentioned across Russia, China, Mongolia, Indonesia,
Yeah.
quite a wide geographic spread.
Do we have any specific examples of projects?
Yes. One concrete example mentioned is the Dahdasht 3D HRES IP project in Iran.
Yeah.
It involved significant Russian and Iranian personnel, both in the field and in the office. And they used a really large-scale setup. Source lines up to 13 kilometers long, survey lines up to 15 kilometers. So definitely capable of large industrial-scale deployment.
And what are the results? the economic impact?
Well, there's one example cited from Western Siberia. It showed an estimated economic efficiency, basically, the value generated for the customer of over 1.5 billion US dollars.
1.5 billion from one project area.
That's the figure mentioned, yeah, with gains attributed to finding an extra 4,285,000 tons of oil. So the point is, it's not just about finding resources, it's about unlocking potentially massive economic value through better targeting.
Huge potential upside then. What about other regions? You mentioned Ukraine earlier.
Right. In Ukraine, there's a key investment project noted by a company called JSC SPC Ukrenaft Invest.
Okay.
They're focused on developing oil resources in the Belusti block, that's in the Odessa region near the coast. They've reportedly discovered over 177 million tons of geological oil reserves there using these methods.
177 million tons.
Oh, that's substantial.
Very substantial. And they're working to increase extraction, which is obviously critical given Ukraine's ongoing energy needs and shortages.
Absolutely. Now, you also mentioned it goes beyond just oil and gas, something about diamonds.
Yes, that's where it gets really interesting. There's a proposal directed towards Pakistan's military intelligence, actually.
Pakistan's military. Why them?
Well, the proposal is to use RAL-F1 not just for hydrocarbons, but specifically for kimberlite exploration.
Finding those diamond pipes again?
Exactly. In places like the Western Arabian Shield in Saudi Arabia and also regions near China, the explicit goal is finding precious minerals, specifically diamonds.
And how accurate did they claim to be for finding kimberlites? The proposal claims the technology can identify kimberlite pipes with up to 85% accuracy down to depths of 5,000 meters.
5 kilometers deep for diamonds? Wow.
Yeah. And there's a Philippine company mentioned as being behind this initiative. They're apparently looking to diversify because their major gas project, Malampaya, is expected to run out around 2027.
So looking for new frontiers. Makes sense.
And speaking of new frontiers...
So where are we going now?
Off-world, actually.
Mars.
Mars. Potentially other places. The technology is also proposed for detecting and potentially mining deep sources of water, gases, salt deposits on other celestial bodies using satellite orbits.
So using the satellite-based AFS-IP-LB system.
Presumably, yes. Imagine finding water ice reserves or sources of methane for fuel deep beneath the Martian surface. It could be fundamental for establishing any kind of long-term presence there, creating livable conditions.
Okay, finding water on Mars using this. That's quite a vision.
Yeah.
But now, let's shift gears again, because the claims for the RAL-F1 algorithm go even further, right? Far beyond geology.
That's right. This is where it enters truly extraordinary territory. Predictive capabilities.
Predicting the future.
Well, the creators assert it can predict future events in what they call open systems, and crucially, without needing additional simulations. They seem to suggest traditional simulations are limited by established scientific stereotypes.
Okay. Predict what kind of future events?
The range is, well, vast. The algorithm is claimed to forecast cryptocurrency market movements.
Seriously? Like Bitcoin?
Bitcoin, Litecoin, Ethereum are mentioned specifically, and oil prices, too.
Oil prices? Okay, maybe that's closer to their core area, but still.
But they give an example. A 2019 forecast for Brent and WTI oil prices reportedly predicted a black swan event.
Which one?
The drone attack on Saudi Arabia's oil facilities. They claim the forecast saw it coming, allowing for advanced preparation.
Predicting a specific geopolitical event like that based on, what, market data? Or the algorithm itself?
That part isn't entirely clear from the sources how it makes that leap, but that's the claim.
Okay, that's bold.
Yeah.
What else?
It extends into meteorology claims of accurately forecasting atmospheric phenomena, into medicine.
Medicine? How?
Exploring its use for predicting cell growth and development. The idea is potentially saving lives by, for example, forecasting cancer recurrence before it's clinically detectable.
Predicting cancer recurrence.
Now, and even predicting massive global threats.
Okay, now I'm really intrigued. What kind of global threats?
The proposal just using it to study Earth and the universe to predict and potentially address things like meteorites, earthquakes, floods, even pole displacement.
Natural disasters, okay.
But also wars, epidemics, famines, even crimes.
Predicting wars and crimes. How could an algorithm based on Lorentz forces possibly do that?
That's the multi-billion-dollar question, isn't it? The mechanism isn't explained in detail in our sources, just the claim itself. It seems to imply some underlying universal pattern detectable by their method.
It sounds almost omniscient. And you mentioned a very current context, too, Ukraine.
Yes. The algorithm has apparently been recognized as useful by the National Security and Defense Council of Ukraine.
Useful for what?
This acknowledgement, dated September 14, 2022, specifically relates to its claimed ability to predict the intensity and the main target areas of Russian bombardments on Ukrainian territory.
Predicting bombing intensity and location. Based on what input?
Based on, quote, historical statistical information. So, presumably feeding past attack data into the RAL F1 system to forecast future patterns.
That's incredibly impactful, if accurate.
Absolutely. Using predictive analytics in active warfare.
Okay, so taking all of this together, the deep Earth scanning, the resource finding, these extraordinary predictive claims,
Yeah.
what's the sort of human and geopolitical dimension here? Let's start with the creator, Vadim Shroff.
Right. He's based in Kyiv, Ukraine, noted as the founder of a company called Horodotska Neftogazova Company. His background is in geology and geophysics, master's and bachelor's degrees from Moscow State University, actually, and he received a diploma from the Russian Ministry of Natural Resources back in 2010 for contributions to oil and gas exploration.
So, Russian academic background and recognition, but now based in Kyiv.
Correct. There are also some more personal details included in the sources, a DNA analysis showing primarily Slavic and Baltic heritage with no detected Jewish DNA. And it's also noted that he was apparently considered a political prisoner in Ukraine between 2022 and 2023.
A political prisoner. The details around that aren't specified.
Not in the material we reviewed, no.
Sure.
Just the statement itself.
Okay. Now, the sources also draw some parallels.
Yeah.
Controversial ones, perhaps, regarding current Ukrainian policies.
Yes, they do. And we need to be clear here, we're reporting what's in the sources, not endorsing any viewpoint.
Absolutely. Neutral reporting is key.
The sources discuss the policy of Ukrainization. That's the effort to strengthen national identity, language, culture, and resist Russian influence. It's presented as understandable and even necessary during wartime. But the sources also raise questions about some methods used. Things like mobilization practices. One Polish document is cited comparing them to World War II raids, and also the banning of opposition parties under martial law. These are presented as points of discussion or criticism within the source material itself.
Okay. And this leads to a historical parallel they draw.
Yes, a specific one. The 1968 Prague Spring in Czechoslovakia.
When the Soviet Union invaded.
Exactly, and the sources state quite pointedly that the invasion was lobbied, developed, and carried out by people from Soviet Ukraine.
From Soviet Ukraine, meaning ethnic Ukrainians within the Soviet leadership.
Yes. Key figures like Marshal Grechko, who was the Soviet defense minister at the time and was of Ukrainian origin, were involved, and troops from military districts located in Ukraine participated in the invasion.
Okay, that's a specific historical claim. What's the connection they're trying to make to today?
Again, stressing neutrality here, the sources are explicit that this is not meant as an equivalence between modern, independent Ukraine fighting an invasion and the former Soviet Union.
Okay, that's a crucial distinction.
It's crucial. It's presented more as a historical case study and maybe a warning. The core idea or paradox they seem to explore is that, well, quoting loosely, in the fight against a system perceived as authoritarian, methods could be used that are reminiscent of it.
Highlighting the difficult choices and potential compromises a nation makes under extreme duress, fighting for survival.
Exactly. It points to that incredibly complex, challenging dynamic inherent in such conflicts.
Understood. And shifting focus slightly, the sources also touch on the broader global context, specifically mentioning the U.S.
Yes, briefly, it references a recent statement from the U.S. Department of Justice about a shift from a nation at peace to effectively a nation at war.
In what sense?
Primarily regarding security concerns, mentioning worries about potential Iranian sleeper cells and noting statistics about Iranian nationals crossing the border illegally.
Okay.
And it also touches on proposed significant budget cuts to federal agencies like the FBI, ATF, and DEA.
And the controversy around those cuts.
Right. Critics argue these cuts could undermine national security and public safety, despite proponents claiming they can do more with less, by prioritizing street-level operations over bureaucracy. It's presented as a point of current political contention in the U.S.
Got it. Wow, what a deep dive this has been. We've gone from satellites mapping oil deep under granite
Hmm.
to algorithms predicting
Right.
stock market swings, maybe even the intensity of military bombardments.
Hmm.
It really does stretch the mind.
It absolutely does. The potential of these technologies, if the claims hold up, to reshape our understanding of Earth's resources and perhaps even our ability to anticipate future events.
It's immense.
But, as we've explored these extraordinary claims, especially around RAF-1, its supposed ability to observe and predict events across so many different fields, it really brings up a fascinating and I think crucial question for you, the listener, to consider.
Okay.
If we increasingly develop tools like this, tools that claim to bypass our traditional ways of observing, analyzing, predicting, what might that ultimately mean for things like human intuition, for our own decision-making processes, perhaps even for our very definition of what knowledge is?
That's a deep thought. If an algorithm knows better or faster, where does that leave human judgment?
Exactly. So as you reflect on everything we've discussed today, maybe consider how these incredibly powerful new capabilities might interact with those persistent human factors, the geopolitical forces that always shape our world.
A lot to think about. We definitely invite you to keep exploring the implications of technologies like these. Technologies that seem determined to blur the lines between what we know, what we can discover, and what might just be predicted.